Okay, sorry for the delay in getting going there. All right. I'm going to review my most missed questions. So if 85% of the class or more got it right, I'm going to consider that one. Probably pretty much everyone knows how to do it. If you want me to go through some of those with you, you just email me but email me by Friday so that I can review it for you. All right, so here we go. All right, these were troublesome. There were two of these. This one is Sammy Wright, who's a 23-year-old with cystic fibrosis. I can't read because there's a thing there, but weighs 75 kilograms, 5'6". He's checking out at the pharmacy, and you work at Kroger or something, and you notice that there's other things in his basket. And considering he has cystic fibrosis, you're kind of nosy and you look through the basket. What would you caution him about? Bananas are great. Reese's Cups, probably not the greatest, but again, these folks don't have to worry too much about weight gain, or they do have to worry about diabetes, but I wouldn't caution them about that one. How about the guaifenesin? This one is maybe the one that's tricky on this. Guaifenesin really is supposed to help thin mucus and help you cough out whatever you need to cough out. There's no evidence that this is helpful enough that we should be recommending it, but there's nothing that's dangerous about it in a cystic fibrosis patient. So if it helps them, great. I would probably not say anything about the guaifenesin. However, the Robitussin is a cough suppressant, right? It has dextromethorphan in it, I think, and it's going to cause cough suppression, which we do not want in cystic fibrosis. So I would only choose the Robitussin. I guess I can't write on this. Okay. Oh, wait, I can. I would choose the Robitussin. And this is the one I want. That's the one that I would caution them about. This last choice is you're not worried about any of them, but we are worried about the Robitussin. Okay. Next. This is a similar question where we're being nosy about the checkout. And this patient has been started on Trikafta, which is that miracle drug. So he's on one of our new drugs that makes all the difference. That is, we have to be concerned about 3A4 and P-glycoprotein. So he's checking out at the pharmacy, and you notice other things in his basket. Again, oh, grapefruit juice. Okay, that's a no-no, right? Because that affects 3A4 the 3A4 enzymes in the gut, and will affect absorption. So this one we don't want. So which one would you caution them about? Well, this is a yes. We caution them about grapefruit juice. What about Benadryl? Antihistamine dries up secretions. Do we want that in cystic fibrosis? No. So we would say this one's a worrisome one as well. So this one's because it interacts with the Trikafta. This one is because it's a bad idea in CF. And we already know we're worried about Robitussin because that's also worrisome in CF. So we would have to mark all three of these to be correct. Okay. How about this one? This one's when we get into a little bit of math. All right, he weighs 65 kilograms. Is it okay to dispense this number of capsules per meal for him? Now, I noticed that in my notes, what I always learned was 6,500 units of lipase per kilogram per meal is the upper limit before you have a risk for colonic strictures. This pen is the worst. So we want to stay below that. But I noticed in my notes, it can go down to there's somewhere in my notes where it says 6,000 units per kilogram per meal. And there is a note that it's best if you're at 2,500 units per kilogram per meal. Now, that's what's best. It does, but this is where we get into trouble, right? And what's more important is probably making sure that the patient's getting their nutrients than worrying about colonic strictures at a lower level. So I expected to use 6,000 or 6,500. So 6,000 times 65 kilograms. So the kilograms will cancel, and that's going to give us X units per meal. So 65 times 6,000 is 390,000. 390,000 units per meal, and he's getting 40,000, and he's getting 5 capsules per meal. So 5 times 40 is 200,000, right? 5 times 4, yep, 20,000 units per meal. So yes, this is safe, isn't it? And you're even you're still over that, but let's see. Well, what's 2,500 just for grins? 25, oopsie. Times 65. Ideally, we'd be like at 162.5, but we would accept this. So I made this a bonus. If I would have said what is the most acceptable, maybe I would say that, but is it okay to give this? Yes, it is okay to give this. All right, now we get into our aminophylline, theophylline dosing. So Kevin Hess is a 68-year-old man with emphysema, severe COPD, who's admitted through the ER with shortness of breath and a cough. He's 6 foot and 85 kilograms and has hypertension and COPD. He also smokes 1.5 packs per day and takes lisinopril, hydrochlorothiazide, albuterol, and tiotropium inhalers. He started on Cipro 2 days ago for possible infection. So the things that we're worried about here is he has severe COPD that will affect clearance. He also smokes, and he's now on Cipro. These other drugs shouldn't matter. Okay, please recommend an intravenous loading dose of aminophylline for Mr. Hess to reach theophylline goal of 15, round to the nearest 50. So a loading dose is pretty simple, right? And we're getting IV, right? So loading dose is going to be our target concentration times our volume. We have no drug on board, so we don't have to worry about already having drug. But we do have to worry about salt form. Do we have to worry about bioavailability? No, because we're giving it IV. So our loading dose, our target is 15 milligrams per liter. Remember, that's in theophylline, and we want our answer to be an aminophylline, which is why we have to add the salt form there. Times the volume of distribution, which in this case is 0.5 liters per kilogram. Times what's his weight? I see a weight on here. Yeah, 85 kilograms. Question is whether he's obese or not. Let's see, he's 6 foot, so you get 2.3 times every inch over 5 feet, so it's going to be 12. Plus, I forget what the kilograms is right now off the top of my head. I do know that it's 110 pounds for a man. So we'll do it in pounds first, but that's in kilograms. I can't do that. So it's 5 pounds. It's better if I do kilograms. I need to go back and remember what that is. 12 times 5 plus 110. 12 times 5 plus, so that's 170 pounds. So 170 pounds divided by, whoopsie, 2.2 is 77.3 kilograms. So 77.3 and he's 85. So 77.3 times 1 is 92. So he's not obese. Okay. But he's 85 kilograms. Okay, so 85 times, and then I have to put in my salt form here. 85 times 0.5 times 15 divided by 0.8. So I got 796.875, and we're going to round to the nearest 50 milligrams. So our loading dose is going to be 800 milligrams of AM. If we, the ideal body weight equation, I don't know what's wrong with me, but I have a brain fart. 50 kilograms plus 2.3 kilograms per inch over 5 feet. So that's times 12, just to make sure I get similar answer. Yeah, 77.6 kilograms. So that's the same. Times 1.293, and he's only 85, so he's not obese. Okay. So we've got the loading dose of 800. And we're going to calculate the initial IV maintenance drift. So now we have to consider clearance, right? So we have to do a guess of his clearance. We don't know his clearance. He hasn't had it before. So we're going to start with 0.04 liters per kilogram per hour. He weighs 85 kilograms. So that's our liters per hour. And then he has severe COPD, so we have a factor of 0.8. And he also smokes, so we add a factor of 1.6 because it speeds up the clearance. And he also is on Cipro, which is I gotta move that. I think I can move it, maybe I can't. 0.7. So what's his clearance going to, what is our estimate of his clearance? We don't know this to be the answer. We're just guessing, aren't we? So 0.04 times 85. Sorry, 0.04 times 85 times 0.8 times 1.6 times 0.7. So I got a clearance of 3.046 liters per hour. That's our guess. Okay. So our CSS average that we're shooting for is 15 milligrams per liter of theophylline. This is going to be a drift, so we don't have to worry about bioavailability, but we do have to worry about the salt form because we want to have aminophylline. So our salt form is 80% theophylline, so 0.8 goes in for our salt form. Bioavailability is 1. Dose rate is what we're solving for. And our clearance guess is 3.046 liters per hour. So 3. That's a point there, just so you can see it. So that times 15 divided by 0.8 gives us a dose rate of 57.12 milligrams per hour. So what do we want to do? We are going to round it to the nearest 5. So that's going to be, let's see, it's 2.12, so 7, 8. So it's probably 55. I think I gave you credit for 60 as well. Milligrams per hour. And that's that. All right. Sorry, my pen is so crappy. All right. Thank you. Let me know if you have any further questions. Expect similar kinds of questions. Maybe some other questions on the remediation. But you probably need to practice this a little bit if you didn't do well. Make sure you check the rounding too, the rounding rules. Okay. And I'm going to be out of town after Sunday. So if you have any questions or want to meet with me, please do so by Saturday, this Saturday. And I won't be back till after Thanksgiving. So sorry about that. All right. Thanks so much. Bye.